All right. Now, a set is usually represented with a capital letter, while the element of that set is usually represented in a small letter, and it usually uses a curly bracket. You can't use you can't use parentheses, and you can't use braces. You only use the curly bracket. For example, if I have set A to be something like this, so this means set A is a set of elements A, B, C. So now let's see application of some of our symbols. If we have A, this simply means A is an element of set A. We can also have this. It means B is an element of set A. But if we have this, it means F is not an element, or is not a member of set A. F is not a member of what? Set A. So this is how we deal with this element of set. Element of set simply shows the members which are in a particular set. So this type of notation, whereby they show you everything, is referred to as graphical notation. It's referred to as what? Graphical notation. We can also have, for example, we also have what we refer to as singleton set. Singleton set. Singleton set. Singleton set is a set that contains only one member. That contains what? Only one member. For example, we can have set A. This is a singleton set. This is a singleton set because it has only one member. But there are problems at times where you see some people will write something like this. And they start arguing. They say this one is an empty set because it's 0. No, this is not an empty set. This is a singleton set. Reason why it is a singleton set is because 0 is also a number. 0 is a number, therefore it's an element. So since it stays here, then 0 is an element. This set is a singleton set because 0 is a what? Element of this set. So this is what we refer to as singleton set. Then when we talk about cardinality, if I ask, what is the cardinality of set A, this set A? Cardinality, as I told you, is what? Number of elements in a set. So the cardinality of set A is 1, 2, 3. It has only 3 members, so you just write 3. If I have set B to be 1, 2, 3, 4, 5, and I ask, what is the cardinality of set B? The cardinality of set B will be 1, 2, 3, 4, 5. It has 5 members, therefore the cardinality is 5. If I have a set C, and this set C contains A, B, C, 1, 2. And I ask, what is the cardinality of set C? Cardinality of set C will also be 1, 2, 3, 4, 5. It has 5 members, so you say cardinality is 5. So now, let's see how we can translate set. For example, look at this question now. List the members of the following sets. This is set number 1. The set A gives us this. So now we are asked just to list the element. Now let's list the element. Let us translate and then list the element. As I said before, in the previously, I said this symbol stands for such that, this one stands for and, this one stands for less than or equal to, this one stands for element. So now, to translate this set, we say X such that X is an element of natural number and X is less than 5. x is less than 5. So now from here now, x is less than 5 and x is an element of natural number. What are natural numbers? Counting numbers. And that counting number is less than or equal to 5. That means any counting number smaller than 5. So what are the counting numbers? We say they are counting numbers. That is from 1 to... So let's start. 1, 2, 3, 4, 5. We stop at 5 because they said less than or equal to 5. But if this or equal to is not there, then this 5 will not be there. So, but because the or equal to is there, therefore 5 will be there. It will be included. So now this is the elements of the set. So don't ever expect that you will be given this type of questions and to solve. It's like the person is giving you 50% of the answer. So he will give you like this. You will be the one to translate the set, then you now solve. Then another one, let's talk about set B. Set B says x such that x is an element of positive integer and minus 5 is greater than or equal to x, x is less than or equal to 5. Whenever you see these two symbols coming together, it simply means from minus 5 to plus 5. Wherever you see these two symbols coming to meet, it simply means the range starts from here to here. So let's say from minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. This will be the numbers. But they told us that the x is a positive integer. That means anything negative will not be included. So these ones will not be included. And also 0 is a neutral integer, it will not be included. So since they say x is an element of positive integer and is within the range of minus 5 to plus 5, so it must be from the positive integers, which include 1, 2, 3, 4, and 5. So these are the elements of the set. Now, this one is the confusing one, right? They said x such that x squared is equal to y cubed. X squared is equal to y cubed. And x is an element of natural number. X is a natural number and its square is also the same thing as its cube. It's a natural number and its square is also the same as its cube. So if you check all natural number, 2, if 2 square is not equal to 2 cube, it's not equal to, because 2 square is 4, 2 cube is 8, 3 and so on, it can never. But if you check 1 square is the same thing as 1 cube. 1 square is 1, 1 cube is 1. This means that 1 is the only natural number that when you square it and when you cube it, they are all the same. That means this set C contains just this. So we say this set C is a singleton set. How we get it? So now let's move to the next part. Alright, so now look at this question now. It says x such that x squared plus 3x squared plus 3x plus 2 is equal to 0. Now you are given a quadratic equation. So now, okay, and x is an element of natural number. Now let's say we are given this and you are asked to list the member of this set. So to get the members of this set, so now what you are going to do is you solve this quadratic equation. You bring it out. We have x squared plus 3x plus 2. So there are two ways is equal to 0. It's either you use factorization method or you use almighty formula, but I don't like calling it almighty formula. I prefer calling it general formula because only God is almighty. So now I prefer using factorization because it's very simple. How do you do factorization? Just draw a tree with two branches. Up here, place this number 2, and between the trees, place this number 3. Now, what you do is bring the factors of 2. What are the factors of 2? We have 2 and 1. This is the only thing you can divide 2 by. You can only divide 2 by 1 and divide by 2. It cannot be divided by 3. It cannot be divided by 4 and so on. So now, what you do is, these are the only factors. If there is another one, add them. But for 2, these are the only 2 factors. 2 times 1, can it give you 2? If yes, check again. 2 plus 1, will it give you 3? Or let me change this place to negative, to make it more complicated. So now, let's deal with our tree. 2 and 1 are the factors of 2. 2 times 1 will give you 2. But 2 plus 1 will not give you minus 3, because this is minus 3. Will not give you minus 3. So now you use another way. Minus 2 times 1 will not give you 2. So add minus to this one. Minus 2 times minus 1. Minus times minus will give you plus. 2 times 1 will give you 2. Now minus 2 plus minus 3. Minus 2 plus minus 3. This plus minus 1. This will be plus minus is minus. Minus 2 minus 1, which is equal to minus 3. So it gives you these 2 values. So that means those 2 factors are what? This. So now you open 2 brackets like this. You drop the first x here, drop the second x here. You have already done for these 2, and you have observed minus 2 and minus 1. So you say x minus 2 and x minus 1 is equal to 0. So from here you say it's either x minus 2 is equal to 0 or x minus 1 is equal to 0. So it's either x is equal to 2 or x is equal to 1. So now that means the 2 elements here are what? 2 and 1. So you can now say set D is a set of 1, 2. Because 1 and 2 are natural numbers. But if any of them is not a natural number, you will not put it. And if all of them are not natural number, you put empty set. So that is that for this one. So now we are going to the next one. Let's see. Okay, so now look at this one now. Assuming we are asked to give the cardinality of the following set. Set A, B, and C. We are asked to give the cardinality. So now we asked, what is the cardinality of A? Cardinality of B? Cardinality of C? I told you, wherever you see this small n, it simply means cardinality. What is cardinality? Number of members in a set. All these ones are members. How many members are there? That is what cardinality is talking about. So the cardinality of this set is going to be 1, 2, 3, 4, 5. It has 5 members. So the cardinality will be 5. Now, how many members does this one have? 1, 2, 3, 4. It has 4 members. The cardinality is 4. How many members does this one have? 1, 2, 3, 4, 5. The cardinality will be equal to 5. So now let's move to the... Alright, now the next thing we are going to talk about is subset and superset. Subset and superset. When we say something is a subset of something, that means something can be found inside something. For example, if I say level 1 class. Level 1 class is a subset of what? Of Bayero University Kano. Do you understand? Microbiology is a department, right? So that department is contained inside where? Bayero University Kano. That means microbiology is a subset of Bayero University Kano. So now if you check, 2 can be found in A. Look at the members of B. 2 can be found in A. 4 can be found in A. And 6 can be found in A. So we can say B is a subset of A. So if B is a subset of A, then definitely A will be a superset. A superset of B. When B is a subset of A, then A will definitely be the superset of B. Now look at C. C, we can find 1 in A, we can find 3 in A, we can find 5 in A, we can have 7 in A. So that means all the members of C can be found in where? A. Then that means C is a subset of A. And since C is a subset of A, then definitely A will be what? Superset of C. So B is a subset of A, that means B can be found in A. C is a subset of A because C can be found in A, while A is a superset of B, meaning A contains B. A is a superset of C because A contains C. Now look at D. D contains the same number of the same element as A. So in this case, you will not use normal set. You say improper subset. So you say D is a subset but equal to. So that is what we refer to as improper subset. So it's a subset that is equal to, that means improper subset of what? A. So D is an improper subset of A, while A is an improper superset of D. So this is how we deal with subset and superset. Then the set, this set now that contain all other set, this set that contain all other set is referred to as universal set. The set that contains all other set is referred to as universal set. So now let's go to the next part. Alright, now you can see we are given universal set and we are given subsets. So now we are going to use these things to find what we refer to as complement of set. But if you check you realize that our sets are not given to us in form of in a good form. We have to transform the set. So let's translate the universal set. The universal set here says 1, 2, 3, dot, 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 means 1, 2, 3 to 10. So now if we bring them out, it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, for set A, they say x such that x is even. That means the even numbers in this place. So now let's bring out the even numbers. What are even numbers? Even numbers are numbers that can be divided by 2. So it will be 2, 4, 6, 8, and 10. And then they say B, x such that x is odd. Odd numbers are numbers that cannot be divided by 2. 1, 3, 5, 7, 9, and that's all. And the last one say x such that x is prime. What is prime? Prime numbers are numbers that can be divided by 2 distinct numbers, 1 and itself. So take note, people usually make this mistake of putting 1 as a prime number. 1 is not a prime number. Prime numbers start from what? 2, because 2 can be divided by only 1 and itself. Then 3 can be divided by only 1 and itself. Then what? 5. Then what? 7. Then what? That's all. Because 9 can be divided by 3. That's why we will not include 9. 9 is an odd number but not a prime number. So now we have listed the element of the set. So now, but they're asking us for the complement of that set. So if they ask you for complement of a set simply means what is in the universal set, but it is not inside the set. What is in this universal set, but is not in the set. So if I ask for a complement, A complement simply means what is in universal set but is not in A. So now let's go and see. 1 cannot be found in A, so we write it down. 2 can be found, we forget it. 3 cannot be found. 4 can be found. 5 cannot be found. 6 can be found. 7 cannot be found. 8 can be found. 9 is not found. And that's all because 10 can be found. Now the next one is B complement. B complement. What is in the universal set and is not in B? That is what we refer to as B complement. So now let's see. What is in this place and it's not here? That is 2, 4, 6, 8, and 10. And finally, C complement. C complement will be 1,